All right, we are on to section 11.7, graphing sine functions. I'm also going to include section 11.8 in here as well because it's the exact same thing except it's going to be cosine, so some values will change, and that's really about it. So our goal here for today is to graph the function in the form of y equals a times sine of bx. You can see that right there. We'll talk about what a and what b are. So the first box here says review. I went ahead and filled this out ahead of time because it will take a little bit of time to complete. And for the sake of the video, I just did this so I didn't have to sit here and watch me just write values in. But I would pause the video if I were you, fill in the values, these coordinate points, for example, as well as the angle measures. And if you want to know where these came from, it came from these special right triangles we've been talking about. So for example, 60, 30, 90 triangle. And we talked about the relationship. So the short side would be x. This would be x times the square root of 3, and then 2 times x. And then this thing here is called the unit circle. And essentially, in a roundabout way, what it does is make those x's 1 or 1 unit. So it's just the square root of 3. It's just 1, and it is just 2 times 1 or 2. And then, so for example, if you want to find cosine of 60 degrees here, you would go adjacent over hypotenuse. So cosine of 60 equals 1/2. And then with this, we also included this idea up here of sine. If you want to write these as coordinate points, sine is the y value, cosine is the x value. It stems from that previous lesson where we had all these relationships like sine equals y over r, cosine equals x over r, and so on. But I said back then, and I'll say it again, if you just remember that sine deals with those y values, cosine is the x values. If you're given a coordinate point, it all works out the same. So here's how you would use this unit circle, and really, so something else for you. The only thing you really have to know is this first quadrant right here, because if you go through and you take a look at the other quadrants, it's just the same numbers, except we have some negative values instead of all positive. And that's where these 4 letters in the corner come from. A, C, TS or ASTC if you go quadrant 1, 2, 3, 4. And that just tells you again where these trig functions are positive. So in the first quadrant, they're all positive. In the second quadrant, only sine is positive. And if you take a look here, sine is my y values. And you look at all my y values, they are all positive. In the third quadrant, only tangent is positive. And then in the fourth quadrant, only cosine is positive. And then the other thing here that you might want to take note of is tangent is just sine over cosine if you're given coordinate points, or again, y over x, if you want to think of it like coordinate points, how we're used to. It does not matter to me. So I'm going to keep referencing this table here, or this unit circle, for the purposes of today. When we graph, we're going to pick values of sine and cosine, and then we're going to plug them in. So we're going to have to calculate. Basically, it's going to be some numbers like this. So we're going to skip here example number 1 because we really don't know how to graph them. You can graph this the traditional way where you pick values, but first I really want to talk about like some vocab: period, cycle, amplitude, minimum value, maximum value, and so on. So first of all, the domain for a sine function is all real numbers. You can plug in any real number you can think of. Our range is going to be somewhere between -1 and 1, or negative a and a. A would be our amplitude. We'll talk about that here. Periodic is repeating patterns that continue indefinitely, because that's what sine and cosine functions are. They're just waves that continue on forever. A cycle is what we're going to be graphing. It's the shortest repeating pattern. So for example, sine goes like this, and then after that it starts to repeat itself. A period is going to be the horizontal length of each cycle, And then in general, our period length is 2 pi, but we can change that, and we'll talk about that here in a second. And the minimum value m, our maximum value big M, minimum value little m, and then the amplitude, the last real thing that we need to talk about here, is the vertical height of these waves. So, taking a look, how do you find the amplitude? So again, we're going to be looking at sine functions in this form, and then cosine here in just a little bit in the same form, just different trig function. To find the amplitude, you just take the absolute value of a. So that would be the number right in front of your trig function. And then to find the period, so this is going to be the part we actually need to do a little bit more with. It's always going to be 2 pi over the absolute value of b. So then we'll take a look here, some examples right below. The graph of y equals 2 times sine of 4x. The amplitude's 2, that's pretty straightforward. But then to find the period, you would take 2 pi, divide it by your b value, and then reduce. So pi over 2 would be the period. And again, what that means is between 0 and pi over 2, we have 1 cycle. After that, we just start repeating again. And then you can see there's another example here for you. And then there are 5 key values. So I'll talk about how to find those 5 key values here in just 1 second. But the main 2 that you need are, we're always going to start at 0. And then we're going to end at wherever our period ends. So for example, this one right up here, we're going to start at 0. We're going to end at pi over 2. And I'll talk about how to get the other 3 values for our table. Alright, so here we go. First example is y equals sine of 1/2 x. And I'll just put the generic form right above it again for you. So a times sine of 1/2 x, or not 1/2, b. So a is our amplitude, the number out front here. If you don't see one, it's just 1. And what that means is if I'm graphing, it means I'm going all the way up to 1 and all the way down to -1. It's the vertical distance from the x-axis, both positive and negative. Our period is going to be 2 pi divided by our b value here, so divided by 1/2. And you can divide 2 by 1/2, or you could just rewrite this as 2 pi times 2 if you take the reciprocal of that denominator, and we would get 4 pi. So what that means is if I start here at 0, I'm going to end out here at 4 pi. I'm going to get my generic wave, something like that. We'll graph it a little more specifically here in a second. What that also means is for my table, I get 0 there, and I'm going to end out here at 4 pi. So then the question becomes, how do you fill in the other 3 x values? Because technically you can pick them, but we kind of want to be a little more specific with trig functions because we're looking for certain behaviors here. So the easiest way for me is just to start by finding this value here. So what I'm going to do is find halfway between 0 and 4 pi, which hopefully we can figure out is 2 pi. And then I'm going to go between 0 and 2 pi, so halfway between 0 and 2 pi is just pi. And then halfway between 2 pi and 4 pi would be 3 pi. So now what we need to do is plug these values into our function. And we'll worry about the a value if there is one later. You can see just like always we have this a times y column. But we do need to worry about that 1/2. So y equals sine and then 1/2, and we're going to plug these values in. So you start with 0, for example, and if you simplify, you get sine of 0 degrees or 0 radians. So if you scroll back up, you look at our table. Here is 0, and then sine is my y value, so sine would be 0. So sine of 0 is 0. So right there. Okay, the next one is pi. So same thing. You're not just going to take sine of pi. You have to plug this in. So we'll go y equals sine of 1/2 times pi, or pi over 2. And what you should probably remember, or try to figure out if you don't remember, is what is pi over 2 in terms of degrees, so that you can use this table up here, because this is all degrees. And if you want on your own, you could certainly add radians to it, which I would probably encourage you to do. But oh man, let me jump back down there for a second. What I would like to do is just draw a quick little sketch here, x and y axis. So in terms of radians, and this is usually how it's going to work with our graphing trig functions, but in terms of radians here, we have 0. This would be pi over 2, or 90 degrees. This would be pi. This would be 3 pi over 2, or 270 degrees. This would also be 2 pi here. So we're going to pick, basically it's going to end up being these 4 values all time. Not all the time, but most of the time. So anyway, but sine of pi over 2 would be 90 degrees. And if you look at 90 degrees here, the sine value is 1. So we're going to plug 1 in here. So I forgot to split my graph, or my graph up here. So I have 4 pi, in the middle was 2 pi, in between 0 and 2 pi was just pi, in between 2 pi and 4 pi is 3 pi. So at pi, I'm up at 1. So put a little dot there. Okay, now we have to do the same thing, but for 2 pi. So I'm going to erase my work here for a second. If you plug in 2 pi, you get sine of 1/2 times 2 pi, which is just sine of pi. If you look down here, pi is 180 degrees. You look over here at 180, you'll find that sine is back at 0. You kind of start to notice a pattern here. So at 2 pi we have 0. So then we do the same thing for 3 pi. When you plug 3 pi in and simplify, you will end up with 3 pi over 2, which is 270 degrees. So scroll up quickly. Sine of 270 is -1. So we'll come down here to -1. So here's what we have so far. And then you can probably guess what it's going to look like. It's going to end up back here at 0. And you can do the math really quickly. So y equals sine of 1/2 times 4 pi. Or if I simplify, sine of 2 pi, which is back at 0, which should be the same value as we had. So initially it looks like a lot of work, but after a little bit of practice, you'll start to see some patterns here. Let's take a look here at one more graphing sine, and then we'll do some writing, figuring out amplitude, period, stuff like that. So graph y equals 2 times sine of x over 4. So the first thing I'm going to do, I just don't like the format, so I'm going to write it as y equals 2 times sine of 1/4 x, and then hopefully you can see a and b clearly. So the amplitude here is just your a value. It is 2. And in a nutshell, what that means again is that you're going up here to 2 and you're going down here to -2. It's the distance from the x-axis that your sine wave is going to travel. The period, again, that's what we're going to end up graphing here. But it's the horizontal distance now. So again, you take 2 pi, you divide it by your b value, so divide by 1/4. This happened in the last 2 examples, but it's not always going to be like this. But you can rewrite this as 2 pi times 4 if you take the reciprocal of this fraction. 2 pi times 4 is 8 pi. So that means I'm going to start here at 0, and I'm graphing all the way out to 8 pi. So in my table, my first x value will be 0. My last one will be 8 pi. And I'm going to treat it the same way as we just did. So I'm going to start by finding my middle number here. And in order to do that, you need to figure out the middle of 0 and 8 pi. which would be 4 pi. It's halfway between those two, so I'm going to add that to my graph. And then 0 and 4 pi, the middle of those two would be 2 pi. So I'll add that to my graph, and then the distance, or the middle of 4 pi and 8 pi would be 6 pi. And I'll add that to my graph as well. And so you do the same thing, okay, we plug 2 pi in, so y equals, again, we'll worry about that a value down here, just like always when we have that a value out front of an equation. But y equals sine of, let's go 1/4 times, well, if you plug 0 in for sine, you're always going to end up at 0, so I'm not going to do that one again. So we'll start here at 0. But if you plug in 2 pi and you simplify that, you are trying to actually figure out the sine of pi over 2, which conveniently enough, we found up here when we plugged pi in, sine of pi over 2 was 1. And again, here comes the pattern, or at least hopefully here comes the pattern that you're starting to recognize. So pi or 2 pi, plug in 2 pi, I get 1. When I plug in 4 pi, I'll do this one with you again. So 1/4 times 4 pi. If you simplify, it is just sine of pi, which is 180 degrees. You can scroll back up and look at this one if you want again, but there it is. It is 0. When you plug in 6 pi, if the pattern continues, sine of 1/4 times 6 pi is just sine of 3 pi over 2, which we found up here. Sine of 3 pi over 2 was -1. Let me get that in there. And then the last one should probably be 0 again, because that's where one cycle is going to end. You're going to start at 0, you're going to go up, down through 0 again, down to your bottom, and then back up to 0, and it's going to end there. So where does the a times y come into play? Well, you just take that y column, multiply everything by 2, so 0, 2, 0, -2, 0, and then you can kind of cross that out if you want. But then you have your point. So we're going to start at 0, 0. Then we're going 2 pi up to 2. 4 pi, we're back down at 0. 6 pi, we're down here at -2. And then 8 pi, we finish at 0. So our function looks the exact same as the one we just did. The only difference is these values down here change. I mean, it's all pretty much the same from there on out. So before we move on to cosine, which is very similar, it's not going to start in the same spot, of course, because sine of 0 and cosine of 0 are not the same thing. But let's first talk about amplitude and period just a little bit more. So if I give you a function y equals sine of pi x, hopefully the amplitude, there's no questions about that. It's the value out front, so it would be 1. Here it would be 3. To find the period, though, we have to do a little bit of work. So you always start with 2 pi divided by your b value. So this one, pretty straightforward. If I simplify, my period is 2. So what that means is if I'm on my horizontal axis, I start at 0, I end here at 2, and then if you were to split it up, we got 1, 1/2, and 3/2, or 1.5. It's up to you. So that's how we would graph that sine function. And if you had to take a guess, it's going to look something kind of like that. Or it goes up to 1, down to -1. This one, my b value here is 1. So we're going to take 2 pi divided by 1. Well, we just get 2 pi. So again, what that means is if I'm graphing, I'm starting here at 0. I'm ending at 2 pi. And then to fill in the points, you just start by finding the middle, which is pi, and then splitting up each one of those. So 0 and pi, the middle is pi over 2. Here it would be 3 pi over 2, and again, it's going to look something like that, where we're going up to 3, down to -3 because of the amplitude. But the last thing here with the sine functions, and like I said, we'll get over to cosine here. The last thing is to write equations. So if I tell you the amplitude's 2, and I'm trying to write an equation in this form, what I have here is a. So right now I know y equals 2 times sine of, and then we have to figure out what b is. So in order to figure out b, what we did was we took 2 pi divided by b, right? So that's what we've been doing all the way up here. You can see it's right here too, 2 pi divided by b, 2 pi divided by b. That's how we got this right here, 2 pi divided by b, 2 pi divided by b. So that's how we're going to find b. So 2 pi divided by b, now in this case, they've already done the work, so we're working it backwards. So what we know is that 2 pi divided by whatever the b value is going to equal pi. They told us the period. So what we can do is make this pi over 1, and we can cross multiply. So 2 pi equals b times pi. And then we can solve this little mini equation. So we divide both sides by pi because it's just a number. Those cancel, b equals 2. So that would be my final equation. Okay, I'm going to try another one, probably going to hop off to the side here, but my amplitude A is 1/2. And then if I want to find my b value, I take my period, set it to 2 pi over b, and then you can make it over 1, and then cross multiply. So 3 pi times b equals 2 pi. We can divide both sides by 3 pi to get b by itself. So the pi's cancel, the 3's cancel on the left side, so b equals 2/3. So your equation would be y equals 1/2 sine of 2/3 x. That was not ideal. Try that. 2/3 x. So there's a couple more there you can try, but I want to hop down to cosine really quickly because everything's the exact same except our values here, what we get out of each of these functions is going to be a little different because if you scroll up, sine and cosine are not always the same. You know, sine of 30, for example, is 1/2, where cosine is a square root 3/2. So it's not always going to be the same. We're mostly looking at these values right here, though, just so you are aware. All right, so graphing cosine section 11.8. So let's see if we can treat this one the exact same way. So first of all, the generic form looks the exact same. So y equals a cosine of bx. So my amplitude A is 1. My period is 2 pi divided by my b value. Well, my b value is also 1, so it's just 2 pi. So what that means is we start at 0, we end at 2 pi. So start at 0, end at 2 pi. And again, we want to split it up in even increments. So find the middle between 0 and 2 pi. Find the middle between 0 and pi. And find the middle between pi and 2 pi. So 3 pi over 2. So when you plug these values into your function, I'm going to erase this quick. Here's our function. Y equals cosine, and we're going to start with 0. So if you don't know what cosine of 0 is, and again, you'll see the pattern like you did here. It's 0, 1, 0, negative 1, 0 for sine. It's going to be a little different for cosine, but same kind of thing. Cosine of 0 now, man, we got kind of a mess here. But cosine of 0 is 1 this time. So instead of starting at 0 with the sine function, we're actually going to start up at 1. So let me add that. Oh, I forgot to add these values. So pi, we said pi over 2, and 3 pi over 2. Or, you know, I can just draw this sketch quick so I don't have to keep going up. So, because we're always going to be dealing with these quadrantal angles on the axes. So the point here would be 1, 0. This would be 0, 1, negative 1, 0, and 0, negative 1. And then again, sine is the y values, cosine is the x values of those coordinate points. So maybe that'll make it a little bit easier. So if I want to find cosine of pi over 2, for example, that's up here. It's the x value, so it is 0. So my amplitude is 1. Let me fix this quick. So we're going up to 1, down to negative 1. My first point was 0, 1. Pi over 2, I'm at 0. And then next I want to find cosine of pi. So pi would be over here at 180 degrees. It's the x value, so it's going to be negative 1. So that's going to put me down here about. The next one would be 3 pi over 2, which is down here. Again, it's the x value, so we're back up to 0. And then the last one would be 2 pi, so it should be the same as what you started with, or 1. So I'm back up here to 1. So it's hard to kind of get a good gauge of what this should look like, because it looks like a V, but actually what we have is we have a nice little curve going on, and it's kind of curving up, and then it should be coming back down and repeating that same pattern. So it looks kind of like a sine function that just got shifted a little bit to the left or to the right, depending on how you want to look at it. So I'm not going to go through this page again because it's all the exact same. You can take a look here. We still call cycle the same thing. That's what we're going to graph, one cycle. A period is how long that one cycle is. The standard period length is 2 pi, but we found in the last section is that could change depending on the b value. Amplitude is still the vertical height. So we'll do one graphing example here. So my amplitude is going to be a, or 1/2. So again, what that means is I'm going up to 1/2, and I'm going down to negative 1/2. That's all that means. My period is 2 pi over my b value. My b value is right there, so it's just 1. So we're going from 0 to 2 pi. And again, split this up into even increments, so it would be pi over 2, and 3 pi over 2. The nice thing is we found cosine of all of these, and the values are the exact same as before because our b value is 1. But again, if my b value was different, this top row would be different, which means that when you simplify, you're going to end up basically finding cosine of the exact same 5 numbers anyway. But if I just use what I've already done, I know my second row should be 1, 0, negative 1, 0, 1. So 1, 0, negative 1, 0, and 1. And then my last column says take a times that column you just wrote, or the row, last row's middle row times your a value, so it'll just be 1/2, 0, negative 1/2, 0, 1/2. And then you can cross that out if you'd like. Plot those points, so 1/2, 0, or 0, 1/2. Pi over 2, 0, pi and negative 1/2, 0, or 3 pi over 2 and 0, and then 2 pi and back up to 1. And again, it looks like a V, but please try your best to draw some curves up here so you can kind of see the curvature of the function. And then same thing here with giving the amplitude and period. Nothing changes. Amplitude is A, so it would be 2. Period is 2 pi over your b value. My b value is 1. So for example, the second one here, my amplitude is 3. So I'm going up to 3, down to negative 3. And my period is 2 pi divided by my b value. You simplify, it would be 2. So that takes care of sections 11.7 and 11.8. 3.8, graphing sine and cosine.